All right, today we are going to talk about the periodic table and its organization. And I love talking about this because I don't think that people understand all of the information that just looking at the periodic table can give us about lots of things that are really important for chemistry, like atomic radius, valence electrons, ionization energy, electron affinity. And so we're going to look at those and talk about how it's important and why they're organized like they are. So to talk about that, we're going to start with our organization. So originally the periodic table was organized by Mendeleev in the 1800s. And he was actually just doing lots of experiments with the different elements and noticed that there were different patterns that kept coming up over and over and over. And so he tried to organize them in some way. He started organizing it by an increasing atomic mass. Like that was the first thing that he did is organized it by increasing atomic mass. And when he did that, he started to notice that other properties were also lining up too. And so he started organizing them and moving them around into different groups and periods, similar to what you see on your periodic table today. But he noticed that there were some spaces because we didn't have those elements yet. And that's really amazing to think about, that in the 1800s, that he was actually leaving spaces. So you can see here on Mendeleev's periodic table, leaving those spaces, thinking about like he knew an element existed because of the atomic masses and because we know we can't have like part of a proton. And so he knew they existed, but we didn't discover them yet. Now, this is the original periodic table, and you can see that he has groups still in here. He had some different periods, and some of those stuff still rings true today, and some of it's been moved around and named just a little bit differently. So you can see on this periodic table, all of the elements and sort of when they were discovered. So there have been 5 elements discovered since 2000, which is really important to think about, that science is constantly changing. And so you can see down here these 5 elements that were discovered since the year 2000. So just in the last 20 years that we've still been discovering elements. There's also like different projects. So the Manhattan Project is very famous about nuclear radiation, and all those blue ones that are very radioactive are ones that were discovered during that project time too. Now, periodic tables don't always look like this, right? We can have one that looks like this. This is a periodic table, and it shows their periodic relationship. And so actually, if you look closely, you can sort of see parts of their electron configuration here that are shown by the different groups, and then they're color coordinated with this. And they have their names in there. It's just a little hard to read on the screen probably, but they have a different type of periodic table as well. So we might use this for different reasons. It could be helpful for different reasons. Then I have this one that is organized by their shapes. So S, P, D, and F, right? Those shapes that we had been talking about with electron configurations. It has their energy levels. So this would be a 1s2, right? Because it's white. And so they have those different levels there that you could go through and do this with for a periodic table as well. Like this is just another way to organize it. And then there's this one that came out after Mendeleev's, and he tried to make some more connections with it, talking about how the dark lines are the ones that, so the dark black lines are the ones where they have the same type of outer electron shells. The blue lines are belonging to the same group, and the red ones show some secondary principles that they're related to in some way, shape, or form. So different periodic tables, they don't always have to look like ours, but ours that we use gives us lots of information, and that's what we're going to talk about today.